Have you ever found yourself just perpetually tired? Like dragging through the day even after what felt like a full night's sleep?
Mm-hmm. Or, maybe you're grappling with some stubborn chronic issue.
Exactly. That brain fog that just won't lift, or maybe unexplained weight gain, or just that general feeling of being off.
Right. Despite trying all the right things, cutting calories, hitting the gym, trying to manage stress.
Yeah, and it feels like you're constantly running on empty,
Yeah.
just unable to really thrive.
Well, if any of that sounds familiar, then you're definitely in the right place today.
We're taking a really deep dive into something pretty revolutionary, actually. A sort of paradigm shift in how we understand our health.
Yeah.
Bioenergetics.
Yeah, our mission here really is to fundamentally transform your perspective on wellness. We want to move beyond just, treating symptoms in isolation.
Which is often where conventional approaches kind of fall short, isn't it?
It can be. So instead, we're going straight to the core, like the very foundation of life itself, understanding the fundamental role of energy in every single cell of your body. Right. And through exploring a wealth of insights from leading voices in this field, what really emerges is this powerful, almost undeniable truth.
Which is?
That a profound lack of energy, right down at the cellular level, truly underlies, well, virtually all chronic conditions and the symptoms we experience so much in modern life.
That's precisely it. Imagine your body not as this complex machine where you just swap out broken parts or treat symptoms one by one.
A reductionist view, yeah.
That's the sort of conventional view. And look, it's useful for certain acute situations, absolutely. But it often misses the bigger picture when it comes to chronic health stuff.
Definitely.
So instead, let's try to cultivate a different image. Think of your body as like a vibrant living garden.
I like that.
You wouldn't just pull weeds, which are kind of like symptoms, without ever looking at the soil, would you?
No, of course not. The soil's health is key.
Exactly. For your garden to truly flourish, to produce, bountiful harvests and resilient plants, it needs the right environment, enough light, clean water, and crucially, incredibly healthy soil.
And in our analogy, that soil health is...
It's your internal energy, your robust metabolism.
Mm-hmm.
So this deep dive into bioenergetics is really designed to equip you with the knowledge to cultivate that inner garden.
Giving it the fertile ground and abundant energy it needs to truly thrive, heal, and honestly probably surprise you with its vitality.
And this isn't just like abstract theory, is it?
Yeah.
Something stuck in textbooks?
Not at all. The insights we're unpacking today are about practical, actionable understanding for you.
Right.
They're designed to empower you, to help you make truly informed choices that build a resilient foundation of abundant, usable energy.
Allowing your body's own innate intelligence, its profound capacity for healing and self-regulation, to finally work its incredible magic without constantly fighting this uphill battle. Okay, let's really unpack this then, because bioenergetics might sound a bit complex, but the core concept, like you said, it's remarkably elegant, surprisingly simple once you grasp it.
It really is.
So at its heart, what is bioenergetics and how does it fundamentally differ from how we typically view health?
Well, what's truly fascinating about bioenergetics is its central kind of unifying idea. Energy is the absolute driving force behind everything. All bodily functions, every repair process, every thought, movement.
Even the structure itself?
Absolutely. Every single structure in your body, from, microscopic protein folding in a cell right up to the macroscopic beating of your heart, it all requires a consistent, efficient supply of energy.
Okay.
And this bioenergetic view stands in, pretty stark contrast to the reductionist approach that's so prevalent in modern biology and medicine.
Right, the one that treats systems separately.
Exactly. That approach often treats your gut, your brain, your hormones, your immune system as sort of separate, independent entities. And while, look, that separation can be incredibly useful for studying individual parts in isolation,
Sure.
it can unfortunately lead to symptom-focused solutions that frequently miss the holistic, interconnected, bigger picture of what's truly going on.
And the why here is absolutely critical, isn't it? Because this is where the practical application really hits home for people.
Definitely. From a bioenergetic perspective, a fundamental lack of usable energy at the cellular level isn't just like a contributing factor. It truly underlies virtually all chronic conditions and those persistent symptoms we commonly experience.
So we're talking about things like fatigue, brain fog.
Everything. Persistent soul-crushing fatigue, that frustrating brain fog that just won't lift, unexplained weight gain that seems to defy diet.
Chronic infections, maybe?
chronic infections that keep coming back, or even seemingly unrelated issues like poor digestion or hormonal imbalances. These are all really, in essence, rooted in a pervasive, often hidden cellular energy deficit.
Wow.
So the ultimate goal in the realm of bioenergetics is, at its core, remarkably simple, but also profoundly impactful.
Which is?
To ensure that your energy supply consistently and significantly exceeds your energy demands.
Okay, supply needs to be greater than demand.
Exactly. When that balance is not only maintained, but, tipped firmly in favor of supply, your body can function optimally, prevent degenerative processes, repair itself gracefully, and truly flourish with vitality.
And how does the body make this energy?
Well, the primary process for cellular energy production, the sort of powerhouse engine within practically every cell, is mitochondrial respiration.
Right, the mitochondria.
This incredible process efficiently generates ATP, adenosine triphosphate, which is basically the body's universal energy currency. It powers everything.
So it really isn't just about how many calories you eat, is it? That's where that traditional model, the simple math equation, kind of falls short.
Completely. This is about understanding the intricate dance of how your body actually produces, distributes, and utilizes that energy, not just clinging to this simplistic calorie intake versus calorie expenditure model.
Much more nuanced.
Far more nuanced, more sophisticated, and ultimately a more accurate way of looking at what truly drives metabolic health and well-being.
Okay, so let's talk about energy supply then. If it's not just calories, what is it?
Right. So when we talk about energy supply, we're specifically talking about the usable energy your cells can effectively extract and produce from the food you consume, primarily in the form of that ATP.
Okay.
Think of food as raw fuel, but it's not ready-to-use energy right out of the box, so to speak.
It needs conversion.
It requires a sophisticated conversion process within your cells, and this conversion critically depends on a whole array of specific vitamins and minerals acting as essential cofactors.
Like spark plugs or lubricants for the engine.
Exactly like that. Without these crucial biochemical helpers, the cellular engine simply can't run efficiently no matter how much fuel you throw at it.
And this is where it gets really interesting and probably surprising for many people listening. There are significant factors that can actively block or severely inhibit this energy production, right? Even with supposedly healthy foods.
Oh, absolutely. We're talking about various forms of toxins. These can include things like chronic gut infections or metabolic endotoxins.
What are those exactly?
They're potent inflammatory byproducts from certain bacterial activities in the gut, technically called lipopolysaccharides or LPS. They can really gum up the works.
Okay. And food toxins too.
Yes, specific food toxins that can irritate your system. And a massive, often overlooked culprit, which we'll definitely dive into more, are certain types of fats.
The PUFAs.
Polyunsaturated fats, PUFAs, yes. They're specifically highlighted in bioenergetics as potent inhibitors of this vital energy production process.
Okay, so that brings us right to the calorie equation, the calories in, calories out model. Why is it so flawed from this perspective?
Well, a calorie, at its most basic, is just a measurement of heat, right? The energy released when food is burned in a lab.
In a bomb calorimeter, yeah.
But our bodies are not simple furnaces, just mindlessly incinerating everything we eat. The human body is this extraordinarily complex, dynamic, adaptable metabolic system. It doesn't just burn calories linearly, it intelligently responds to its environment.
That's the absolute key, isn't it? That adaptability, it can't be overstated.
Definitely. Your body constantly adjusts its energy expenditure based on its perceived energy availability, what it thinks it has access to. It's incredibly smart, a master of survival.
So if it thinks there's a famine.
Exactly. If it perceives a state of semi-starvation, maybe from prolonged calorie restriction or excessive exercise without enough fuel, it will instinctively, powerfully slow down its metabolism. It starts shutting down what it considers non-essential functions, like robust digestion, reproductive health, immune vigilance, all in a desperate effort to conserve energy and prevent starvation.
And there was that experiment that showed this really clearly.
The Minnesota starvation experiment, yes. A landmark study. It dramatically illustrated the severe negative effects of calorie restriction, not just physically, but profoundly on mental and emotional well-being, too.
Wow.
It's a stark reminder that just cutting calories isn't a neutral act. It triggers a deep evolutionary stress response.
And this leads right into the idea that not all calories are created equal then.
Precisely. The sheer calorie content of food is actually a remarkably poor basis for making informed food choices. Some energy sources, particularly refined carbs, especially those polyunsaturated fats, can actively undermine efficient cellular energy production. They create metabolic roadblocks.
Whereas other foods.
Conversely, nutrient-dense, easy-to-digest whole foods provide not just calories, but the necessary raw materials, those vital cofactors we mentioned for optimal clean energy production.
It's like that fuel quality analogy we talked about before the show, counting logs on a fire.
Right, you could have 3 logs of wet, damp wood. They'll just smolder, produce minimal heat, lots of smoke, leave a mess.
Yeah.
Or you could have 1 log of perfectly dry, seasoned hardwood that burns brightly, efficiently, filling the place with warmth. That dryness is like the pro-metabolic quality of the food.
So 2,000 calories of junk food versus 2,000 calories of nutrient-dense whole foods. Completely different metabolic effect.
Profoundly different. As different as a sputtering, smoky fire is from a roaring campfire. It's truly about the quality of the fuel, not just the quantity.
Okay, so that's energy supply. Let's flip to the other side. Energy demands. What does that encompass beyond just, going for a run?
Right. It encompasses a far broader spectrum than most people realize. Energy demands include literally all bodily functions and activities that require cellular energy to operate. Everything.
And this is where many of us probably overlook significant, maybe silent energy drains that just chip away at our vitality.
Absolutely. Less obvious but incredibly important demands include chronic mental stress or excessive brain activity. Just constantly churning thoughts can be a massive energy sink. Your brain is highly metabolically active.
Makes sense. What else?
Sleep deprivation is huge. Not just feeling tired, but fundamentally disrupting energy regulation. Even things like prolonged exposure to electromagnetic fields, EMFs from our devices.
Really, EMS.
The research is ongoing, but there's evidence it can be a stressor. And definitely dealing with chronic inflammation or persistent infections, these can dramatically drain your energy reserves without you even realizing the extent of it.
So there's a trade-off happening all the time.
Absolutely clear trade-off with profound implications. If you have excessive energy expenditure in one area, overexercising, persistent emotional stress, battling an infection, there's inherently less usable energy available for other critical functions.
Like digestion, immunity.
Robust digestion, a fully functional immune system, cellular regeneration and repair, even maintaining healthy hormone balance. All these foundational processes need energy.
So the key is striking the right balance.
And ensuring adequate, consistent energy is directed to the most essential healing and regenerative processes that underpin true vitality. That's the goal.
Okay, so we've laid the groundwork. Bioenergetics is this energy-centric view. Now let's zoom in on the building blocks, the macronutrients, carbs, fats, proteins. But through the specific bioenergetic lens, how do they actually impact cellular energy? Let's start with carbs, because, man, they get a bad rap sometimes.
They really do, but carbohydrates are absolutely vital for maintaining stable, consistent energy levels, particularly for your brain function and central nervous system.
Why specifically the brain and nervous system?
What's often misunderstood, especially with popular low-carb diets, is that your brain and nervous system can't directly use fat for energy. They rely almost exclusively on glucose, which primarily comes from the carbs you eat. It's a fundamental physiological reality.
And it's not just about having glucose, it's about efficiency, right?
Exactly. It's about the efficiency of the energy conversion. Carbohydrates, specifically glucose, are oxidized, burned far more efficiently than fats.
Meaning more ATP.
More ATP, that energy currency, and importantly, more carbon dioxide per molecule of oxygen used. This clean, efficient burning, producing ample CO2, is fundamentally what we're aiming for to support robust cellular metabolism.
So how much carbohydrate do we actually need then, from this perspective? Is there a minimum?
Based on human physiology, a minimum of around 150 grams of carbohydrates per day seems necessary for optimal brain function, healthy thyroid activity, adequate mucus production, which is important for digestion and respiratory health, and crucially, for stress reduction.
But that's a minimum, right? It depends on the person.
Oh, absolutely. It should always be tailored to the individual. More active people often need significantly more, sometimes upwards of 300, 400 grams or even more, depending on their output.
And timing matters too. Keeping blood sugar stable.
Paramount. Frequent carbohydrate intake, ideally every few hours, is crucial for maintaining that stability and keeping those powerful stress hormones like cortisol and adrenaline down.
Which is why low-carb diets can be problematic long-term for many.
That's one of the main reasons, yes. Instead of using readily available glucose, these diets force your body to rely heavily on stress hormones, glucagon, adrenaline, cortisol, to maintain blood sugar levels through gluconeogenesis.
Making glucose from protein, basically.
Exactly. Your body creates glucose from non-carb sources, usually protein. This reliance means you have chronically elevated stress hormones, even if you adapt.
Some people say the stress response goes down after adaptation, though.
Well, while some claim the cortisol and adrenaline response diminishes, that adaptation still comes at a significant metabolic cost. It keeps your body in a subtle, persistent state of stress. Glucagon, at the very least, often stays elevated.
And glucagon isn't ideal.
It's a key hormone often elevated in conditions like diabetes and insulin resistance. It signals a low energy state and tissue breakdown, not healthy metabolic function. It's a survival mechanism, not optimal.
So if your energy needs increased, like from exercise or stress on a low-carb diet, your body just ramps up those stress hormones even more.
Instead of simply using the carbs you could eat to keep them down and fuel yourself efficiently, it's a fundamental difference. For some people, especially starting from a low energy state, this might mean eating every 3 to 4 hours, maybe even more frequently in smaller doses. Consistency is key.
Okay, so what are the ideal carb sources then, from this bioenergetic view?
Primarily, we're talking about organic ripe fruits and fruit juices like fresh orange, pineapple, white grape juice. Raw honey is also excellent. Lighter colors are often easier to digest. Go for organic raw honey to avoid pesticides.
And surprisingly, sugar.
Surprisingly, for many, yes. White table sugar is considered the next best option for those with healthy digestion, especially with polyphenol-rich foods, as it's pure, easily metabolized glucose and sucrose. Also, well-cooked and cooled potatoes, sweet potatoes, white rice, their starches break down readily into glucose.
And what should we be cautious about? What's less preferable?
Generally, corn syrup, especially high fructose corn syrup, is the least preferred. Aggressive processing, chemical refining, often an unhelpful fructose to glucose ratio that can overwhelm the liver.
What about brown sugar or raw sugar?
Less preferable than white sugar because the molasses content can contain irritating caramelized compounds, potentially causing gut issues for some sensitive people. Dried fruits can also be tricky. Concentrated sugar, lack of water, sticky nature can be hard on digestion for some.
So thinking back to the fuel analogy, glucose from carbs is like high-octane gasoline. Clean, efficient burning.
Exactly. It illustrates that fuel mix matters idea perfectly. Trying to run primarily on excess fatty acids, especially PUFAs, is like putting diesel in a gasoline engine.
It might run, but
It'll be inefficient, produce lots of smoke, like lactic acid and reactive oxygen species in the body, and ultimately cause premature wear and tear. Keeping that fuel mix optimal with enough high-quality carbs keeps the metabolic engine purring.
great analogy. Okay, let's shift to fats. There's this common idea that fat is superior fuel because it's denser in calories, right?
Very common misconception, yeah. Propagated by some popular diets. But in the bioenergetic view, it's not just potential energy, it's about how efficiently it's converted into usable ATP in your mitochondria and how cleanly it burns.
And carbs win on efficiency. But fats are still crucial. The real issue, you're saying, is with polyunsaturated fatty acids, PUFAs.
Yes, this is absolutely central to bioenergetics. PUFAs are truly detrimental from this perspective, acting as metabolic inhibitors. Their chemical structure with multiple unstable double bonds makes them inherently unstable and incredibly prone to oxidative damage. They essentially rot inside your body.
Okay, rot sounds bad. How does that happen on a cellular level?
Right, this is where it gets really problematic. When these unstable PUFAs get incorporated into your delicate mitochondrial and cell membranes where energy is generated and exchanged to their kinks, those unstable double bonds disrupt the membrane integrity.
Making them leaky.
Exactly. Leaky membranes impair the efficiency of energy production within the mitochondria. Studies even link the unsaturation index of cell membranes, how many kinks they have, to aging and longevity. More unsaturation, more instability, potentially a shorter, less vibrant life.
And this instability leads to lipid peroxidation. What's that?
It's like a tiny, uncontrolled fire within your cells, a destructive chain reaction. Unstable fatty acid fragments break off, generating harmful free radicals, those unstable molecules that steal electrons and damage things, and toxic byproducts.
And this damage contributes to?
Major contributor to DNA damage, widespread cellular dysfunction, and a whole host of chronic diseases. Cancer, diabetes, neurodegeneration, fertility issues. Plus, these damaged PUFAs can turn into pro-inflammatory compounds called eicosanoids, fueling systemic inflammation.
Wow. And historically, we didn't eat many of these.
very minor components of traditional human diets found in small amounts in whole foods. But consumption has skyrocketed with industrial seed oils, soybean, canola, corn, sunflower, safflower oils. They're in everything processed, used in most restaurants.
Why the big increase?
Largely driven by the misguided diet heart hypothesis, which wrongly blamed saturated fat and cholesterol for heart disease. Looking back, the evidence linking saturated fat to heart disease is actually quite weak. But the dramatic rise in PUFA consumption precisely parallels our modern epidemics of obesity, diabetes, cardiovascular disease. It's a correlation that really demands attention.
What about the connection between PUFAs and cholesterol? Because cholesterol gets blamed too.
Right. Another major reframe needed here, PUFA peroxidation, that internal rotting directly damages the liver's ability to properly synthesize and secrete cholesterol.
So high LDL, bad cholesterol isn't the cause.
It's more accurately understood as a marker of underlying metabolic dysfunction, liver stress, and inflammation, not a direct cause. In fact, oxidized PUFAs themselves, along with those bacterial endotoxins, LPS, are directly implicated in damaging the lining of your arteries, setting the stage for plaque.
Okay, so if PUFAs are like rotten butter in the pantry, spoiling inside us, what are the good, stable fats we should be eating?
We strongly recommend strictly avoiding industrial seed oils and other PUFA-rich foods. Instead, prioritize traditional saturated and monounsaturated fat.
Like what specifically?
Saturated, high-quality butter, coconut oil, palm oil, cocoa butter, traditional animal fats like tallow and lard, full-fat dairy, egg yolks from well-raised animals, monounsaturated, extra virgin olive oil, avocados, macadamia nuts.
And these stable fats are crucial for
Hormone production, maintaining robust cellular integrity, supporting overall metabolic health, aiding efficient energy production. Also, very low-fat diets can be profoundly problematic, leading to hypoglycemia, constant hunger, adrenaline release as the body scrambles for fuel, reduced androgen production.
So we need adequate fat, but the right kind.
Exactly. The right kind is vital for hormone production, cell membrane structure, digestion, immunity.
Okay, last macronutrient, protein. Crucial, yes, but maybe not primarily for energy.
Precisely. Protein is primarily about building block structure, tissue repair, maintaining muscle mass, not the body's preferred primary fuel source.
So how much do we need for those building block functions?
Generally, around 0.6 to 0.8 grams of protein per pound of body weight seems optimal, ideally from easily digested animal sources, meat, dairy, eggs, seafood, for that complete amino acid profile.
Using it for energy isn't ideal.
Not ideal at all. Converting amino acids from protein into glucose, gluconeogenesis, is very energy intensive for the body. Plus, it produces toxic ammonia as a byproduct, which the liver then has to work hard to detoxify into urea.
So excess protein is kind of wasteful and stressful.
Can be, yeah. Places an unnecessary burden on the metabolic system beyond what's needed for structure and repair.
Are there specific amino acids that are particularly important in this bioenergetic framework?
Definitely. Methionine is essential for exporting fat from the liver. Glycine, proline, hydroxyproline, abundant in connective tissues like bone broth, collagen, gelatin, help mitigate negative effects of some other amino acids and really support gut integrity and tissue repair.
What about BCAAs?
Branched-chain amino acids may help decrease liver fat accumulation, and precursors like cysteine, glutamate, taurine are vital for making glutathione a key antioxidant and supporting bile acid conjugation and detoxification.
And how should we consume protein throughout the day? All at once.
Spreading it evenly is key for optimizing its use for muscle protein synthesis and repair. A minimum of about 0.18 grams per pound of body weight per meal is a good guideline to stimulate that process and ensure a consistent supply.
Okay, putting it all together. Carbs, fats, protein. How do we balance them? It feels like it could get complicated.
A suggested starting point, just as a guideline, might be around 40% fat, 40% carbohydrates, 20% protein. But this is where the profound individuality of bioenergetics really shines.
It's not one size fits all.
Not at all. Your specific needs are highly personal. Depends on activity level, health goals, genetics, and crucially, how your body personally responds.
So experiment.
Absolutely. Experiment patiently, track your intake, and meticulously observe the trends. Energy levels, digestion quality, cravings, mood, sleep, body composition changes. And if you're coming off a long-term low-carb diet, expect some initial blood sugar fluctuations. That's normal adaptation as your body relearns how to use glucose efficiently. Be patient with it.
Right, we've covered energy as the foundation and choosing the right fuel. But what about the body's internal operating system? The hormones. This is where calories in, calories out really breaks down, isn't it? Because the body adapts.
Completely. The body profoundly adapts to perceived energy restriction, chronic dieting, prolonged deficits, excessive exercise without enough fuel. It responds by powerfully lowering its basal metabolic rate.
Burning fewer calories at rest.
Exactly, and aggressively ramping up hunger and cravings. It's a primal effort to prevent starvation. Part of that constrained model of energy expenditure, the body tightly controls energy output for survival. It's a fundamental biological drive.
And this explains why restrictive dieting often backfires. The rebound effect.
Precisely. Leading to that frustrating cycle of rebound binging and weight regain, it actually makes future weight loss harder because the body becomes incredibly efficient at preventing fat loss, almost remembering past deprivation.
And hormonally, what shifts happen?
Profound, often detrimental shifts. Decreased thyroid activity, reduced levels of key regenerative hormones like testosterone and estrogen, and a consistent, often chronic increase in stress hormones like cortisol and adrenaline, all designed to conserve energy but at a high cost to overall health.
So this leads to the idea of two main metabolic states, stress versus rest.
Exactly. The sympathetic state, fight or flight, versus the parasympathetic state, rest and digest.
Sympathetic is the stress state.
Characterized by stress hormones, cortisol, adrenaline. In this mode, long-term energy production is inhibited. The body prioritizes breaking down stored energy, glycogen, fat, and even its own tissues, muscle, bone, for rapid short-term fuel. Adaptive for acute emergencies, but chronic activation is profoundly degenerative.
And the parasympathetic.
That's the rest and digest state, dominated by regenerative hormones, testosterone, progesterone, active thyroid hormone. An anabolic state where the body focuses energy on growth, repair, efficient digestion, robust immunity, reproduction. Deep healing happens here.
So restoring health means shifting towards that parasympathetic state.
Fundamentally, yes. Consciously shifting from predominantly catabolic, stress-driven to more anabolic, regenerative, reducing excessive stressors, avoiding significant energy deficits through nourishing food, consistently eating pro-metabolically, supporting natural circadian rhythms.
It's like the emergency generator analogy you mentioned.
Right. Stress hormones are like noisy, polluting emergency generators. When the main power-clean, efficient ATP goes out due to perceived scarcity or lack of fuel, these backups kick in.
They keep you alive, but...
They keep you alive, provide a surge, but they're inefficient, noisy, produce metabolic pollution, high blood sugar, muscle breakdowns, suppressed immunity. You don't want to run on emergency power constantly.
Get the main grid back online.
Get the main grid, your efficient mitochondria humming smoothly with real food and adequate rest. That's the goal.
Speaking of the main grid, let's talk thyroid. It's central to metabolism, right? It's like a thermostat.
Absolutely central. Regulates metabolism and energy production, your body's metabolic thermostat, setting the pace for nearly everything.
And hypothyroidism and underactive thyroid is common, but often missed.
Shockingly common, often underdiagnosed, and frequently inadequately treated. A major misconception is relying solely on TSH, thyroid-stimulating hormone.
Why is TSH not enough?
Because hypothalamic pituitary dysfunction, often from chronic stress, can suppress TSH even when your tissues are hypothyroid, not getting enough active hormone. Your peripheral tissues might be suffering despite a normal TSH blood test.
Due to conversion issues.
Impaired conversion of inactive T4 to the active T3 hormone and diminished cellular energy production right at the target tissue. You really need comprehensive labs, TSH, free T4, free T3, maybe even reverse T3 to see the full picture.
What kinds of things impair that crucial T4 to T3 conversion?
Lots of things. Systemic inflammation, high cortisol, low-calorie diets, and importantly, low-carbohydrate diets.
Why low carbs specifically?
Because insulin actually helps lower stress hormones and increases the activity of the D1 enzyme, which facilitates T4 to T3 conversion. Other factors include environmental toxins, certain meds, chronic sleep deprivation, disrupted circadian rhythms.
Even exercise.
Excessive exercise can signal stress and scarcity, impairing conversion. Even large amounts of uncooked goitrogenic foods like raw cruciferous veggies or soy can interfere.
So it really is like the thermostat analogy. Well, T3 sets the temperature.
Exactly. Active T3 is the thermostat setting. If it's set too low, the house stays cold, no matter how much fuel you burn. Many people are unknowingly trying to heat their mansion body with a thermostat stuck on low.
Fix the thermostat first.
Bioenergetics prioritizes fixing the thermostat supporting thyroid function, not just shoveling more metaphorical coal in vain.
Okay, let's tackle insulin resistance now. The bioenergetic view really reframes this, doesn't it?
Yeah.
Challenges the conventional idea of cells just losing sensitivity.
Completely. From a bioenergetic standpoint, insulin resistance isn't just lost sensitivity at the cell surface. It's the result of underlying metabolic dysfunction, impairing the cell's ability to fully oxidize glucose, burn it efficiently.
So glucose backs up inside the cell.
Precisely. When glucose oxidation is impaired, it builds up inside because it can't be processed efficiently. This internal backup then creates a feedback loop, blocking further glucose uptake from the blood, leading to high blood sugar.
So the cell isn't resistant to insulin itself.
It's resistant to more glucose because it can't handle what it already has. It's effectively full and malfunctioning.
And fatty acid oxidation plays a role here.
A central role in the dysfunction. When cells are forced to burn fatty acids primarily, especially with impaired glucose oxidation, they generate more reactive oxygen species, ROS, those damaging free radicals.
And that affects metabolism how?
It alters the crucial NADH-NAD+ ratio. Think of it like the cell's metabolic battery charge. An altered ratio inhibits key enzymes in glucose oxidation, perpetuating reliance on fat fuel, creating a vicious cycle of inefficiency.
So the surprising part, increasing carbs can help.
Here's the truly counterintuitive part. Yes, increasing appropriate carbohydrate intake can actually improve insulin sensitivity, even in type 2 diabetes.
Oh.
Carbs stimulate insulin. Insulin suppresses stress hormones like glucagon and cortisol. It also reduces fatty acid oxidation, favoring efficient glucose utilization. It helps get the cell back to preferring its clean-burning glucose engine. This same pattern elevated fatty acid oxidation is seen in NAFLD and cardiovascular disease, too.
Okay, next up. Cholesterol, the villain of heart disease for decades. Bioenergetic says, not so fast.
Definitely not so fast. It's a major misconception. Cholesterol is actually a protective player, not the enemy.
Protective how? What are its essential functions?
Crucial protective and essential functions. It acts as a protective adaptation, binding to and neutralizing bacterial endotoxins, LPS, from infections or gut imbalances. So elevated cholesterol can actually be a beneficial protective response to inflammation.
And it's needed for hormones.
Absolutely. Required as the precursor for all vital steroid hormones, testosterone, estrogen, progesterone, cortisol. Also for bile acids, fat digestion, vitamin D, coenzyme Q10, key for mitochondrial energy. And it's essential for all cell membrane structure and function.
What about low cholesterol then? Is that risky?
Truly alarming and often ignored. Persistently low cholesterol, especially in the elderly, is consistently associated with increased risk of serious issues: cancer, dementia, neurodegenerative diseases, hormonal imbalances, even increased death from infection.
So what's the optimal range from this perspective?
Actually considered robustly between 200 and 240 milligl total cholesterol, often significantly higher than conventional recommendations.
So if high cholesterol isn't the cause, what drives it up?
Elevated blood cholesterol is far better understood as a marker of underlying metabolic dysfunction, inflammation, and stress. Major drivers include hypothyroidism, impairs LDL receptor function, chronic infection or endotoxin triggers protective production, and as we discussed, PUFA peroxidation damaging a liver's ability to handle cholesterol properly.
So the takeaway is, address the underlying issues, don't just lower the number.
Exactly. Don't shoot the messenger or remove a crucial protective mechanism without fixing the root cause.
Finally, let's unpack serotonin, estrogen, and cortisol. Starting with serotonin, not just the happiness chemical.
Far more complex. From a bioenergetic view, its main evolutionary role is regulating energy metabolism, coordinating resource distribution for stress response, often at the expense of growth, repair, reproduction.
How does that relate to fatigue?
Well, elevated serotonin during sustained exercise is strongly associated with fatigue onset, as energy is reprioritized for immediate survival when glycogen falls. In the periphery, outside the brain, serotonin promotes efficient energy storage, potentially contributing to fat accumulation and stress.
And the link to depression. This is where it gets really different from mainstream views.
Yes, a significant reframe, explored by researchers like Dr. Ray Peat and others. Compelling evidence suggests depression might actually be a state of elevated, not reduced, serotonin transmission, often acting with high cortisol to shift metabolism towards a catabolic, energy-depleted state, contributing to symptoms like fatigue, brain fog, low motivation. It challenges the whole chemical imbalance theory.
Wow. Okay. And estrogen and cortisol, they often rise together.
Often rise together under chronic stress and also tend to increase with aging. High estrogen can stimulate cortisol and vice versa, creating a cycle that can slow metabolism and raise systemic stress. Estrogen itself can be seen as stress-promoting in some contexts.
And progesterone is the counterpoint.
Progesterone is viewed as the crucial anti-stress hormone. It's both produced from a high metabolic rate and actively supports a high metabolic rate and cellular energy. Think pregnancy, a high progesterone, high metabolic output, anabolic state.
So bioenergetics aims to favor progesterone.
Often aims to support and favor progesterone production over estrogen through strategic diet, like vitamin E, raw carrots to help eliminate excess estrogen, and lifestyle, minimizing estrogen-mimicking toxins.
Okay, moving beyond diet and hormones, what other key factors are essential for optimal energy? Let's talk carbon dioxide. It's not just waste.
Far from it. CO2 has numerous profound beneficial effects. It helps immensely with oxygen delivery to tissues, the Bohr effect, where hemoglobin releases oxygen more readily in CO2's presence. Vital for getting oxygen into cells for energy production.
What else does it do?
Plays a vital role in maintaining proper blood pH balance. Plus, it has powerful calming and anti-inflammatory actions throughout the body, like a natural tranquilizer. And crucially, adequate CO2 is a direct marker of a well-fueled, oxygen-using cell, indicating efficient mitochondrial respiration.
And low CO2 is linked to health issues.
Conditions like chronic edema, glaucoma, epilepsy, heart failure, diabetic neuropathy are consistently linked to cellular hypoxia, lack of oxygen, and a deficiency of CO2.
So if it's so beneficial, how do we increase it?
Best way is efficient mitochondrial respiration via complete glucose oxidation, which produces 50% more CO2 than fat oxidation. Key nutrients like B vitamins, especially thiamine B1, are vital to drive the enzyme complex, pyruvate dehydrogenase, that burns glucose efficiently.
What about breathing techniques?
Simple but powerful things. Consistently breathing through your nose, practicing methods like buteyko breathing, actively avoiding chronic hyperventilation, which blows off too much CO2. These support mitochondrial function and healthy CO2 levels. Supporting thyroid function or strategic caffeine use can also help, but only after addressing underlying issues.
Next, NAD+ and niacinamide, critical for mitochondria.
Absolutely. NAD+ is a profoundly significant coenzyme, essential for healthy mitochondrial function, energy production, and overall cellular vitality.
And niacinamide is vitamin B3, a precursor.
Yes. Niacinamide is a form of B3 your body uses to build NAD plus Ne. It has wide-ranging potential benefits. In obesity, it can help reprogram fat cell metabolism, increase mitochondria, enhance fat burning.
Neurological health.
NAD+ deficiency is linked to neurodegenerative diseases like Alzheimer's. Raising levels via niacinamide can help support brain cell energy. In liver health, it addresses low NAD+ and NAFLD. Cardiovascular health, it supports NAD+ and function in heart cells.
Sounds amazing. But you mentioned warnings about B vitamins. Is there a catch with niacinamide? The Goldilocks effect.
Absolutely a crucial point. More is not always better. Excessive intake of B3, especially certain forms, can lead to a byproduct called 4-PY. Recent research linked elevated 4-PY to increased risk of heart attack stroke.
So caution is needed.
Definitely. While niacinamide is beneficial, start low, maybe 50 milligrams 3 times daily, and importantly, combine it with synergistic nutrients like B1, B2, maybe even methylene blue, which helps regenerate NAD plus aim for balance.
Can't forget the gut, foundational for bioenergetics.
Absolutely foundational, often overlooked. The gut microbiome influences far more than just digestion. A dysfunctional gut barrier, leaky gut, and imbalanced flora lead to chronic systemic inflammation, impaired nutrient absorption, altered appetite regulation.
And those endotoxins again, LPS.
A major underlying factor. When bacterial endotoxins, LPS, from gram-negative bacteria leak into the bloodstream, they can increase estrogen, hinder liver detox, and profoundly impact metabolism, driving a hypo-metabolic state.
So, how do we support the gut barrier? Keep the bouncers strong.
Key strategies. Diligently avoid gut-irritating foods, often industrial seed oils, processed items, individual triggers. Incorporate gut-protective saturated and monounsaturated fats. They protect the liver from endotoxins and stimulate healthy bile flow, a natural antimicrobial, and correct any micronutrient deficiencies the gut needs for repair.
Right, keep the troublemakers out, like the bouncer at the club analogy.
Exactly. If you constantly feed your gut junk inflammatory foods, toxins, stress, that bouncer gets overwhelmed and the riffraff floods in, wreaking havoc system-wide.
Okay, lastly in this section, environmental and lifestyle stressors. How do we minimize their energy drain?
Chronic stress.
Huge impact. Consistently elevates cortisol, affecting appetite, cravings, fat storage, often midsection. Activates the RAS pathway linked to hypertension.
Sleep deprivation. Massive energy drain we often normalize. Decreases leptin, appetite suppressor, increases ghrelin, hunger stimulator, reduces insulin sensitivity, impacts active thyroid hormones T3, T4, even with normal TSH, impairs the brain's waste clearance system, lymphatics.
What about overexercising? Can that be bad?
Surprisingly common issue. Excessive exercise, especially endurance or high-volume resistance training, can significantly increase stress hormones and decrease active thyroid hormone, particularly if you're already hypometabolic. The body sees it as a threat.
And environmental toxins.
Pervasive and growing issue. Plastics, BPA, pesticides, cleaning chemicals, food additives, carrageenan, gums, emulsifiers disrupt thyroid function, burden the liver, have estrogenic effects, all contributing to a low energy state.
So the what doesn't kill you makes you stronger idea, maybe not always true.
This bioenergetic view really challenges that hormesis attitude. Gentle stressors can be positive in an energized system, but stress alone is insufficient and often detrimental without the energetic factors fuel machinery to fuel adaptation. Focus should be on minimizing unnecessary stress and maximizing cellular energy.
Okay, we've covered the principles. Now let's bring it all into practice. How does this energy-centric view help with common modern health challenges? Starting with weight management, because eat less, exercise more often fails.
Exactly. Bioenergetics shifts the focus entirely from restriction to nourishing the body to naturally increase its basal metabolic rate, BMR. Burning more calories at rest makes fat loss easier, more sustainable.
How do we boost BMR?
Key boosters. Build and maintain muscle mass. Muscle is metabolically expensive. Strength training is great for this, plus insulin sensitivity, bone density. And crucially, consume sufficient, easily digested, nutrient-dense whole foods with the right balance of carbs and fats to boost metabolism without digestive distress.
And fat quality matters here too.
Immensely. Emphasizing stable, saturated, monounsaturated fats over inflammatory PUFAs significantly improves metabolic rate and efficiency. The goal is sustainable. Eat the maximum amount of high-quality pro-metabolic food possible while supporting overall health. Gradual, effortless fat loss becomes a byproduct of true health improvement, not a battle.
Next, non-alcoholic fatty liver disease, NAFLD. It's an epidemic. Bioenergetic says it's not just about eating too much fat.
Correct. It arises more from the inflammatory and nutrient-depleting factors of modern life, specifically impaired glucose oxidation and excessive PUFA consumption overwhelming the liver.
So, dietary interventions for NAFLD.
Protein. Crucial. 0.8 g-pounds from high-quality animal sources. Specific amino acids are vital. Methionine exports fat from liver. Glycine, anti-inflammatory, antioxidant. BCAAs, cysteine, glutamate, taurine, support liver function detox.
So this is key, right? Minimize PUFAs.
Absolutely paramount. Minimize PUFAs from all sources: seed oils, nut seeds, fatty fish, often high in oxidized omega-3s, non-pastured pork, poultry. They promote liver inflammation, inhibit respiration, reduce fat export, drive oxidative stress.
Emphasize what instead?
Stable, saturated, monounsaturated fats, high-quality dairy, well-raised meats, coconut palm oil, animal fats, tallow.
And carbs are important for the liver too.
Vitally important. Help lower stress hormones, provide preferred fuel for liver metabolism, drive efficient energy, best sources.
Right.
Ripe fruits, juices, honey, cooked starches, potatoes, sweet potatoes, white rice. Less likely to feed gut dysbiosis, easily metabolized. And don't forget micronutrients. Liver needs B vitamins, magnesium, iron, zinc, copper for energy and detox.
Okay, hypertension, high blood pressure. Conventional view often misses the root causes.
Bioenergetics identifies root causes as mineral imbalances, low salt, low potassium often, and insufficient cellular energy production. This leads to an adaptive blood pressure increase. The body tries to compensate for low tissue perfusion oxygenation.
And the RAS system gets involved.
Chronic activation of the renin-angiotensin-aldosterone system, RAAS, and the stress response cause negative effects. Potassium, magnesium loss, cell swelling, vessel constriction.
You also mentioned challenging the heart as a pump idea.
Briefly, yes. Emerging research suggests the heart facilitates flow perhaps via a vortex, working with the exclusion zone, EZ water lining vessels. This structured water layer, maintained by endothelial cell energy, is crucial for smooth flow. Damage here, for example, from vitamin C deficiency impacting collagen or PUFA damage, impairs circulation, contributing to the need for higher pressure.
So pivotal dietary interventions for hypertension are different. Salt is okay.
Not just okay, essential. Minimum 2-3 teaspoons high-quality salt daily, or to taste, for blood volume, nerve function. Ensure ample potassium, fruits, juices, potatoes. Calcium, magnesium, dairy, greens, mineral water. Favor stable saturated fats, coconut oil, butter, tallow. Strictly avoid polyunsaturated vegetable oils, vitamins, organ meats, egg yolks for fat solubles, A, D, E, K2. Sunlight for DB, vitamins for mitochondrial energy, vitamin C for collagen vessel health. And always sufficient calories, carbs, fats, protein to meet energy needs.
Lifestyle matters too.
Incredibly impactful. Manage stress, avoid overexercising, prioritize sleep, address gut health, support thyroid function. It's a holistic approach to recalibrating pressure.
Finally, autoimmunity. Bioenergetics redefines this completely, not the immune system attacking self.
It reframes it profoundly. Not the immune system mistakenly attacking self, but rather an intelligent response to underlying energy failure and structural damage in tissues. The immune system is clearing out degraded, damaged tissue like a cleanup crew responding to an internal fire caused by energy deficits.
So it's a systemic issue linked to mitochondrial dysfunction.
Deeply linked to widespread mitochondrial dysfunction and insufficient cellular energy production system-wide. Underlying drivers include chronic stress hormones, cortisol pushing towards Th2 inflammatory response, chronically elevated estrogen promotes autoimmunity, while progesterone and testosterone have the opposite protective effect.
This critiques common approaches like AIP or low carb.
Yes. Elimination diets like AIP might offer temporary relief by removing irritants, but often fail to address the underlying metabolic issues and can even increase stress via restriction. Very low-carb diets are strongly cautioned against. Glucose is essential for cellular energy and robust immune function. Immune cells need glucose.
So, bioenergetic solutions for autoimmunity focus on
Foundational diet shift, sufficient, easily digested carbs, fruits, honey, stable saturated monounsaturated fats, gut health, bile, antimicrobial, high-quality animal protein. Minimizing PUFAs is critical. Foundational supplements might include B vitamins, B1, B3 biotin, B2, B6, thyroid support, maybe aspirin, anti-inflammatory, pro-metabolic, taurine, glycine, vitamin C, progesterone, always food first, supplement second. It's a true paradigm shift. Viewing autoimmunity as a response to systemic inflammation driven by impaired cellular energy and tissue damage, restoring metabolic health, fueling cells, balancing hormones, reducing inflammation, clearing toxins becomes the key to long-term remission and genuine healing, moving beyond reductionism towards holistic energy system support.
And there you have it. Wow. We've taken a really comprehensive deep dive into this fascinating world of bioenergetics, from energy as a foundation to tackling modern health challenges.
To recap the core message, it's really this. True, lasting health and reversing chronic conditions isn't about suppressing symptoms. It's about understanding and actively optimizing your body's fundamental energy production and utilization.
Cultivating that inner fire.
Consistently cultivating that powerful inner fire, nourishing it, and profoundly supporting your system's innate intelligence and boundless capacity for healing.
So you, the listener, now have this comprehensive framework, this powerful lens, to understand why certain things impact your health, and importantly, how to make conscious choices that truly support your energy and well-being, moving towards vibrant vitality.
It's really about empowering you to reclaim your health.
Absolutely.
So as you reflect on this deep dive, consider these insights. I want to leave you with a final, maybe provocative thought to ponder.
Okay, let's hear it.
If our modern epidemic of chronic illness is fundamentally an epidemic of energy deficiency at the cellular level, what small, consistent shifts can you begin to make this week to truly fuel your body's inherent capacity for healing and abundant vitality, rather than just, treating its symptoms?
Start small, be patient, experiment with curiosity, and most importantly, really tune into your own body's biofeedback. Your body is always talking, sending signals, and now hopefully you have a powerful new lens through which to listen and respond.